In this video, we're going to take a deep look at the JSON schema. I'm going to go through just a few quick slides and then we're going to jump right into a hands-on example. So first of all, OpenAPI or JSON schema, both of these are things that describe JSON, oftentimes a JSON data feed even though it doesn't have to be, also known as a REST endpoint. OpenAPI used to be known as Swagger, or Swagger documentation. Swagger still exists, by the way, but OpenAPI is what specifically describes JSON for Swagger. And it's what you can use to generate Swagger documentation. JSON schema, on the other hand, also describes JSON, but I found a lot of free online tools for JSON schema, and that's what the focus of this video is. So these two things, OpenAPI and JSON schema, are very similar, but not identical. There are a couple differences between the two. Also, OpenAPI, they can do JSON or YAML, but you tend to see that in a YAML format, where JSON schema tends to be a JSON format. So a few things in the JSON schema. First of all, I like to call it WSDL for JSON, something that describes what a REST endpoint serving JSON should look like. It can be used to validate the data that's coming in. It can be used to generate code for the client or server side. And you can use a JSON schema to automatically create a form, sometimes with validation, using several tools that are available. The latest version at the time of this recording is Draft 07. So at the top of a JSON schema, we're going to see the $ schema with the schema version, $ID, or in later versions they drop the $ from the ID. That's essentially a unique ID of the schema and also serves as a root URL for the href. Title is open text, whatever you want to say there, and description is also open text. These are optional, but definitely a good idea to include. Now, under definitions is where we're going to define complex types like a class or an object. So we'll typically have a name and then a series of properties or fields and attributes. And again, we'll take a look at that when we get into the example in just one more moment. We can have classes or objects that own other classes or objects, and we can easily do this with the $ref indicator. We can also have arrays that own objects, and we can do this with the $ref operator. What you'll see after this is essentially a path that tells us how to get down to the object that we're referring to, and once again, we'll see that in an example in just a moment. Finally, a big reason for having a JSON schema is to add validation. So with strings, we can look at a min and a max length and a pattern. That pattern would be a regular expression. With arrays, we can define a minimum number of items, and we can indicate that they all have to be unique items, kind of like a hash map or a hash set. With numbers, we can have a minimum, maximum, exclusive min, exclusive max, so essentially greater than or equal to, or just greater than. Then another one that I think is kind of fun is multiple of. So you could have multiple of 10, and then only numbers that are multiple of 10 would be included there. So with that, let's jump right into an example. Lesson number 1 is don't reinvent the wheel. There are many nice tools that will generate at least the start of a JSON schema for you. One of my favorites is app.quicktype.io, and what you do is paste the JSON here to the left side and then select JSON schema on the right side. What I like about this is you can also switch and say, I want to generate a C# client, for instance. If I want to use QuickType, what I'll do is I'll grab a unit of JSON. We don't necessarily need to grab the whole thing, but at least a good sample, and make sure that we're opening and closing it properly. So note this opens with a curly, then we have something called specimens and a colon, and then a square bracket. And so we're going to want to end it with a square bracket and a curly as well. So I copy this, I go over to QuickType, I just delete whatever is there, I paste, I make sure I get the end just right, so square bracket, curly. And then once I have that, I can come over here, choose C# or choose JSON schema just like so. So this is a good start of one. We see here we have the $schema, and this is essentially an array of items. So it initially points us down to this path of where we're starting to definitions to welcome. So you see definitions to welcome, and it's telling us that we have an object here, and this object owns an array. Now what's an array? It's a collection of similar objects. Now take a look at this $ref. It's telling us what those objects look like. So definitions specimen for each of the objects that are a constituent of the array. So definitions and then specimen, and this describes the objects that are in our array. So it's an object It has a latitude, longitude, plant ID, specimen ID, common, genus, species, address, and notes. That is, these are the properties or the types that describe that object. And then below that, we have the ones that are required, and in this case it's indicating that all are required based on the sample data that we have passed in. Let's look for a few other examples as well. Here's a look at streetcar blockages and delays for the streetcar in Cincinnati. If we look at the data set, there's a subtle difference here between this one and the one that we just looked at. Notice we have a square bracket indicating an array, and then we immediately have an object that follows it, where the data source we were looking at before essentially made this an object that owns an array, so there were a couple of extra steps. So, sticking with this very first example, let's just remember what those steps were. We start with object, which owns an array. That array owns more objects. In this case, the object is a specimen. Now let's look at the streetcar data, which I've already pasted in. In this case, we start with our schema and we start with our type. And notice the type just immediately begins with array, and then it says, what does the array own? Well, definitions, welcome element, so then definitions and welcome element here. And this welcome element essentially is a class, or if you prefer, each of the individual units as an object, and these represent times that the streetcar was blocked. So you'll see a little simpler schema here because we just jump right into the array and then the elements of that array based on how this JSON starts, versus our plant data where we had an object that owns an array and that array owns more objects. So you see that we actually had a couple of different ref definitions, one for the object that owns the array, and then the next for the elements of the array. One other thing I'll point out about the streetcar data is if we scroll down, we'll see there are some more complex types. So if we look at category, outcome, neighborhood, and then community council neighborhood, you see those do indeed have more refs. And sorry, we're back to the streetcar. This is the streetcar data that we're looking at. So if we look at category, it says it's an enumeration, which means one of these below. So other, automobile, metro bus, traffic delay, fire, traffic delays. Those two probably could be consolidated with a bit of capitalization. Police, and then delivery truck. So what it did is it looked at all the data we passed through, and it said, well, these are the only options I see. I'm going to make an enumeration out of them. Similarly, for neighborhood and community council neighborhood, we have OTR in downtown and over the Rhine in downtown. And that makes sense because that's the only two neighborhoods where the streetcar runs in Cincinnati, so those should be the only two options. Now we go down to outcome, we see removed by owner-operator, unknown, traffic resolved, NA, and resolved by Cincinnati Police Department. Looking at these automatically generated enumerations, I think the neighborhood and community council neighborhood makes the most sense because those are, by definition, the only two places where a streetcar would be blocked. The other ones, category of the blockage, this probably covers most, but there could be others in the future we don't anticipate. So when I clean up the schema, I might be tempted to remove this enumeration just because I don't want to restrict to only those options. Same thing with outcome, there could be other outcomes. But neighborhood and community council neighborhood, those are the only two options, so that makes sense as an enumeration. One more data set that I looked at that was kind of interesting is this one on Cincinnati Open Data Website Analytics, where it's looking at usage of these digital properties that the city of Cincinnati makes available. So once again, it's an array that has an element called welcome element. Lots of different things here. What I found interesting about this is, first of all, it's kind of meta information. It's saying which of this open data are used the most frequently. But another thing that's interesting about this is that I noticed there are some numbers that are double quoted, which was common, if you see here, which was fairly common early on. If you look at the double quoted numbers and other items that are formatted like that, the schema comes out with a type of string because it has to, because it's double quoted, but then it also comes out with a format that says, okay, once you're inside, that's a Boolean, that's an integer, that's a date time, it's an integer, so on and so forth. Now, if we look at the plant places feed of specimens at certain locations, we will see that there are numbers here that are not double quoted, like the plant ID, and also the latitude and longitude are not double quoted. Now, if we take a look at that schema, we'll notice that it just has type number, type integer, not type string, and then format number or format integer. One note I will say is I found that this was a bit easier to deal with when doing validations because it's really based on that type. So let's go ahead and copy this copy the schema, paste into Notepad++, and now we can embellish it a little bit. So we start with the schema. We'll also do a $ID, and for this one I'll say http plantplaces.com, and then comma, and then we'll say title, and we'll say plants with, or let's call it specimens, plant specimens at specific locations, lat LNG. Okay, and then comma, and then we'll say description, a collection of plant specimens near a certain GPS location. We'll leave it at that. That's good enough. Terminate with a comma. Now we get to our definitions. Welcome, type object, that's fine. Properties, specimens, type, array, items, definition, specimens. Required, specimens. This all looks good. This all looks fine to me. So let's go down to our specimens now. Let's take a look at latitude. We can give this more. We can give this things like a description and say, this one's kind of obvious, I guess, but the latitude of this specimen, and then comma, and actually I forgot to comma up there. There we go. And then we can say, because this is a number, we can say minimum. Well, what's the minimum latitude? Minimum latitude is about -90, comma. And then we'll say maximum. And maximum latitude is about +90. Longitude, we can do similar things. So go ahead, just do a little copy and paste here. Description, the longitude of the specimen. Longitude's a bit broader, so we'll say -180 to +180. Plant ID, type integer. Description, unique identifier of the plant. Okay, and the plant ID, nothing's going to be less than 0, so we can say minimum. Let's call it exclusive minimum, because as memory serves, the very first plant ID is not 0, it's actually a positive number. So exclusive minimum means greater than 0, not greater than or equal to 0, but greater than 0. And we can keep going with this. Genus and species, this is where a description's nice, because a species is part of the category of plants, thanks to Charles Linnaeus. So you could put a couple words into that, something like that. But for someone who doesn't know what a species is, that's helpful. Address, notes, again, lots of things we can have there. Now, required, we want to think what's really required here. Is address required? Probably not, because we already have latitude and longitude. Common name, maybe not required. Species is not always required. Notes is not required. So we can do a little tidying up here. At this point, we have a pretty good looking schema, something that maybe needs a couple of more tweaks, but we have taken the very bare bones schema that was generated for us, we've added a bit of descriptive text, and we verified that it has determined the right data types for each of our properties. If not, I could go in here and tweak it. We've given it a description, and we've given it a few validation rules as well. So at this point, we have a JSON schema that we can use to validate JSON that we might be reading in. I cover that in a separate video, and that video is Validate JSON Schema with C# using QuickType and Newtonsoft and Visual Studio 2019. If you're interested, take a look at that, and that's a code example of reading in JSON and watching what happens when it validates, and also when it fails to validate. I hope this is helpful, and I look forward to reading your comments. Thank you.